In the quiet of October 2017, on the slopes of Haleakal in Hawaii, a dot of light betrayed a story far bigger than anyone imagined. A telescope operator noticed a speck moving across the night sky. Nothing unusual at first, but the math that followed appended centuries of assumptions. This visitor was screaming through our solar system at 196,000 miles per hour, faster than any comet or asteroid that belonged to the Sun. Its orbit wasn't bound. It was passing through like a traveler who had no intention of staying. We called it Oumuamua Hawaiian for a scout, or messenger from afar arriving first. But if speed alone was the headline, the details became the plot twist. It had no coma, no tail, no fuzzy glow. It wasn't behaving like a comet. It wasn't shaped like an asteroid. It tumbled and dove end, with its brightness swinging so wildly that astronomers guessed it was up to 10 times longer than. It was wide. Imagine a skyscraper lying on its side and spinning through space. Stranger still, as it receded, it began to accelerate in ways that gravity couldn't explain. No cometary jets were visible, yet something was pushing it along. Some said shard of rock. Others whispered alien probe. One thing was certain. Nothing in textbooks looked like this, and in that moment, the human race realized something sobering: we weren't watching the sky carefully enough. If something this strange could slip by and vanish forever in just a few weeks, what else were we missing? That realization set the stage for a global effort. His skywatching net cast wider than ever before. And in July 2025, that net hauled in something that makes even Oumuamua look ordinary. An interstellar comet, alive with a tail and coma, caught in bound with time to watch it unfold. The first scout startled us. The third showed us what we were meant to see. From the start, Oumuamua broke the rules. The Pan-STARRS telescope spotted it first as a faint point of light, moving just slightly faster than the background stars. That alone wasn't strange. Astronomers discover near-Earth asteroids almost daily, most of them harmless. Most of them following predictable ellipses around the Sun. But the follow-up calculation showed something nobody expected. This object wasn't orbiting the Sun at all. It was passing through. Its orbit was hyperbolic, not elliptical. Picture tossing a ball past Earth, if it's slow enough. Earth's gravity bends its path into an orbit, trapping it. But if it's too fast, the ball swings by once and is gone forever. That's what Oumuamua was doing on a solar system scale. It wasn't ours. It wasn't staying. Tracing the path backward pointed roughly toward the bright star Vega in the constellation Lyra, about 25 light-years away. But here's where things got weird again. Vega wasn't even in that position 300,000 years ago, when Oumuamua would have started its journey. That meant this interstellar rock had likely been wandering for millions, possibly billions of years, crisscrossing the galaxy like cosmic driftwood. Think about that for a moment. While dinosaurs ruled Earth, while the first mammals were crawling through the underbrush, this shard may already have been drifting through interstellar space. While our ancestors learned to paint caves and shape stone tools, Oumuamua was already on its long, lonely trek. And in 2017, purely by chance, Earth's telescopes happened to be looking in the right place at the right time. The sheer odds of catching it was staggering. Astronomers had long predicted that other star systems must eject comets and asteroids the way ours does. But actually spotting one was like finding a specific grain of sand on every beach in the world. Yet, against all probability, there it was, faint, fast, and fleeting. And it wasn't just its rarity that stunned astronomers. It was what it represented. For the first time, humanity had physical proof that planetary systems across the galaxy don't just form and collapse in isolation. They interact, They scatter pieces of themselves. They trade debris across the void. Our solar system isn't an island, it is a node in a vast network of material exchanged spanning the Milky Way. Light curves don't lie. Every 7.3 hours, Oumuamua's brightness shifted dramatically, confirming it was tumbling chaotically. No solar system asteroid behaves like that. One hypothesis said it was a fragment from a violent collision in another system, a shard flung into space when worlds collided. Another suggested hydrogen icebergs form in molecular clouds, only to be sculpted into bizarre needles by sublimation near stars. But both models had flaws. Hydrogen ice wouldn't survive millions of years in space. Nitrogen shards would sublime it too quickly. That left sunlight pressure. The idea, Oumuamua was, incredibly thin, perhaps just a few millimeters thick, with a large surface area. That would make it sensitive to the momentum carried by photons. In other words, a light sail, while most astronomers leaned toward natural explanations. This possibility turned the story into headlines. Harvard astrophysicist Avi Loeb argued that acceleration matched what a thin sheet of material would experience under solar radiation. He didn't claim it was definitely alien, but he refused to rule it out. Extraordinary objects require extraordinary consideration, he said. The debate raged. Was it ice, fluff, or sail? Each option carried consequences, but the object itself didn't care. It was already disappearing, growing fainter each night as it fled the inner solar system. Within weeks, it was gone forever, and just like that, the first interstellar visitor had come and gone, leaving behind more questions than answers. The story could have ended there, but in 2018, a team confirmed the non-gravitational acceleration with rigorous data. Oumuamua was being pushed. But by what? 2 years, the mystery simmered. Then in 2023, a breakthrough arrived. A team proposed that cosmic rays, over millions of years, could split water molecules inside icy bodies. Hydrogen would build up in pockets, trapped like bubbles in a sponge. As the sun warmed Oumuamua, that hydrogen escaped, giving it a subtle thrust, invisible, odorless, and undetectable by telescopes, but strong enough to explain the anomaly. This theory was elegant. It meant Oumuamua wasn't alien hardware, but alien geology, ordinary ice transformed by extraordinary time. Not everyone agreed, but many breathed relief. The universe hadn't broken its own rules, and yet the alien sail idea refused to die, because the truth was, we'd only glimpsed Oumuamua briefly. We didn't have the smoking gun of a tail, a coma, or gas detection. All we had was a fading streak and our imaginations. Whether shard, iceberg, or sail, the lesson was the same. Humanity had been caught flat-footed. The cosmos had sent us a messenger, and we barely saw it. That wake-up call birthed something new, a global system designed not to miss the next messenger. It's called Atlas, the Asteroid Terrestrial Impact Blast Alert System. Unlike traditional telescopes designed for detail, Atlas was built for coverage, for robotic eyes too in Hawaii, one in South Africa, one in Chile. Scan the entire dark sky every night. Each can capture a patch of sky 100 times the size of the full moon together. They sweep up anything that moves. The system runs automatically, comparing each night's images against star charts, flagging objects that shift. Within minutes, computers know what's ordinary asteroids, satellites, cosmic rays, and what's new if something doesn't fit. An alert goes global. The network was built not just for science, but for safety. A rock 60 feet wide can devastate a city. 300 feet wide could wipe out a region. Atlas can spot the small threats days before impact, the medium threats weeks before, and the big ones years ahead. It is humanity's last line of defense and our first line of discovery. And in July 2025, Atlas proved its worth in spectacular fashion. On July 1st, 2025, the Chilean Atlas telescope flagged something faint. At first, it looked routine, another distant rock. But as more data came in, its path looked strange, too fast to open. Hyperbolic. By July 2nd, the Minor Planet Center confirmed it. See 2025 in one Atlas. The third interstellar object ever found. And unlike Oumuamua, this one was clearly active. Through telescopes, astronomers saw a fuzzy cone of gas and dust. This wasn't an inert shard. This was a comet, breathing in sunlight and venting its ices into space. For the first time, astronomers could study a visitor from another star system in detail while it was still inbound, still active, still alive with chemistry. We call it 3I, ATLAS. 3-1, ATLAS is larger than Oumuamua, several miles across. With enough ice to sustain a coma tail for months, its speed, over 130,000 miles per hour, fast enough to cross the continental US. In under 2 minutes, its trajectory points back to the crowded heart of the Milky Way, suggesting it may have been traveling millions of years before stumbling into our skies. Its perihelion closest approach to the Sun will come in late October 2025. By then, its tail may stretch millions of miles. Spectroscopy is already revealing water vapor, carbon monoxide. Carbon dioxide, the same stuff that drives comets here, but with subtle differences in isotopes and dust. Those fingerprints tell us about the temperature and chemistry of the star system it came from. In other words, this is direct material from another planetary nursery. No probes, no rockets, just a comet delivering samples across the void. Oumuamua stunned us. Borisov, the second visitor, reassured us it behaved like a normal comet. Just not from here. And now Atlas has delivered the third. We're entering an age where interstellar visitors will become routine. The Vera Rubin Observatory, coming online soon, will scan the sky with unprecedented sensitivity. Astronomers expect to find 1 to 3 interstellar objects every year. Each will be a messenger. A sample return mission from another star, delivered free of charge. Some will be shards, some comets, maybe one day even planetary fragments. And each will teach us how worlds form, evolve, and die. We used to think planetary systems were islands. Now we know they're archipelagos, trading debris across the galaxy, and maybe, just maybe, trading the ingredients for life itself. In 2017, a strange shard called Oumuamua whispered that we weren't watching carefully enough. In 2019, a comet named Borisov confirmed that other systems shed icy wanderers just as ours does. And in 2025, Atlas caught a living, breathing comet from another star, 3I. ETLAS, giving us months to study it in exquisite detail. The message is clear. The universe is not silent. It sends us messengers, carved from alien suns, bearing the chemistry of distant nurseries. Some come quietly, some with spectacular tales, but all arrive with stories written in ice and dust. The first messenger startled us awake, though. Third proves the door is open, and in the decades to come, as our telescopes sharpen and our surveys expand, we will learn that the galaxy is not a collection of isolated worlds. It is a web of shared history, material, and maybe even life itself. Humanity once looked at the stars and wondered if we were alone. Now the stars send their fragments to us, one cosmic visitor at a time.